Good evening, everybody. It's a pleasure to be here this evening on such a nice event as the TED events. So I think I will start quite rapidly, as I'm only given 18 minutes to talk to you and to hopefully entertain you. And I will also try to make it a little bit interactive. So if you have comments or whatever, if you feel to have some involvement, please do so. So if I can have the presentation. Okay. As Christophe just introduced myself, actually, I'm not in particular an innovation manager, but Creax is a company that's active in the domain of innovation and creativity. And what we actually believe in is that someone, somewhere, already solved your problem. Okay, so we believe that in some way every problem, or nearly every problem, has already been solved by someone, but probably not always within your domain, but maybe there's a big chance that in another domain you can find solutions, ideas to solve your problem. Now, in this 21st century, we actually live in a knowledge economy. Knowledge is all around us. There's overloads of knowledge. It's accessible through the internet. There are databases with valuable information like patent databases and so on. So what we try to do, we really try to use existing knowledge and to try to find how other people solve their problem and to realize technology transfers between different domains. So on the next slide, maybe I can start with a little example and already immediately ask you a question, so feel free to answer it. How could we, if we have a glass of water, how could we get the water out of the glass without touching the glass? So let go your creativity. Straw, yes? Second, there's already one in the audience, yes? Other possibilities? Microwave, exactly, you heat it. Other? Vacuum? Yeah, we can use vacuum to actually get the water out of glass, correct? Other? We have 3 technologies so far. Freeze it. Exactly. Yes. So when you say the glass will break, there was someone in the audience once told me that he would invite his mother-in-law, she would sing, and the glass would break as well. Those maybe some other possibilities? Okay. A sponge, exactly. So what we did here, we did a small brainstorm. We have a problem. We resemble all the specialists around the table, and we start generating ideas. But this happens in an unstructured way. And in a matter of speaking, actually the solutions that we will find to this problem, we are actually limited, although we're all intelligent people, but in effect we are limited to the knowledge of the people here inside the room. Wouldn't it be nice if we could take our glass of water and ask everybody in the world, do you know a solution to my problem? And that's actually what we do. And one way to do it, and an important way to do it, is actually, as I said, to really go and look what kind of technologies do exist to solve this problem. And one important source of information is patent data. All patents are available on the internet. So we go and look and ask the patent database, how many technologies do exist to get water out of my glass? And how we do that is we actually go into abstract. Instead, my specific problem is I want to have the water out of this glass, but in abstract, what I want to achieve, I want to move a liquid. But I'm not the first person in the world who wants to move a liquid. There's lots of domains, industries who already know technologies to move liquids. So we go and look into patent databases, how many technologies exist to move a liquid. We list these up and we look what of these existing solutions might solve my particular problem. So for example, on the next slide, I already show some possible technologies. It's nearly impossible, or it is impossible, to actually do a simple brainstorm and to find all these technologies. But by really looking in a very active way into the patent database, you can find all these technologies. For example, one domain could be discharging liquids from containers. That's a part within the patent database. There's already more than 4,200 patents talking about moving a liquid. So there's a huge amount of knowledge that's available over there. So this is just as a simple example. Now, next slide, please. How do we actually go in abstract? How do we find these solutions? How do we find ideas from other domains? Like every human being, every technology, every product that exists consists of a particular DNA. We all are different. We all have our own particular DNA. That's actually the same with technology or with products. So where we start from is always we list up what are the specific properties of a certain technology or product. For example, if I take a glass, as a simple example again, you can say, okay, my glass is it's immobile, it's transparent, it's hollow, it can contain something, and so on. It has a flat surface, and so on. So I list up all these properties, and these actually are my product DNA. Now, what you can do with this product DNA, you can actually go and look for what other products or technology have similar DNA, so that one can learn from the other. For example, we did some innovation research on a product you probably all know, which is this little rice bag, you know, to cook rice for 10 minutes. Okay, so, but if I ask you, just name me another product which is also in a bag, which goes into hot water, which has to release aromas and so on, what would you think of? Tea, exactly. So I list up all the product DNA of this rice bag, and immediately you make the connection to similar products. Now, between the product DNA of a rice bag and a tea bag, there's about 75% of similarity. But that means also there's 25% difference, technology solutions that one domain knows, but the other one doesn't know. And maybe some of you who like to cook and use these rice bags, you probably have had already the problem that once the 10 minutes are gone, you have to shake and stay before above the boiling water to actually let the water drip out of the little rice bag. Now, if you look at what solutions exist into the tea area, there are some self-shrinking solutions that you get the tea bag out of the hot water, and it shrinks and automatically pushes out the water. Or there is a system with little ropes that you can tear on, and automatically it shrinks and it gets the water out. So these are solutions that exist, that are available within another domain, which you actually could easily transfer from the tea area to the rice bag area. So that's actually what we do. Another example is on the next slide. Yes, so this gives you, this shows you a little bit the process. So we start from this product DNA, and then we make a comparison of similar DNAs to see what technologies we can transfer. And on the next slide, there's another example, which I ask you again. Maybe it will be harder to answer this one, but what have a rubber in a tire in common with whipped cream? Air, yes. Inside the tire, yes. But it's air, exactly. It's already right direction. Now, you probably all know when you have a new tire, there are little rubber hairs on the tire. You know that. So we've been asked to work on that problem. What is actually the problem is when you make a tire, you put liquid rubber into a mold, you compress it, air has to leave, liquid rubber stays in, it becomes hard, and you have a tire. But you always have a little bit of liquid rubber going into the air holes, so that when they open the tire, you have those little rubber hairs on the tire. That is not exactly the problem, but the problem is that there's still some rubber into the air holes. So it's a very labor and cost-intensive process to actually clean all the time these molds. Now, we have been looking into the patent database, went into abstract and said, okay, the particular problem is here the mold to make tires. But in abstract, what do I want to achieve? I want a separation between gas and liquid. And we find the solution into the whipped cream area. When on industrial scale they make whipped cream, they actually put air into milk, but the milk may not enter the air holes neither because of hygiene and so on. And in that area, they already used a filter material which has such a porosity that it separates, air can get through, but liquid stays in. So we transferred actually that technology from the whipped cream area to the tire industry to solve the problem of the tires. You see? So that's about a nice example how other domains, how other industries can solve a problem. Okay? This is the case. So you see little rubber hairs. All right. So that's one area. Now, one direction you can go is you can compare similar DNAs. On the other hand, another direction is every property that you define within your product or technology DNA, every property is something you can change. All right. So if you say, okay, my glass is immobile, that's something you can have variations within that property. You can have something can be mobile, can be immobile. You can add a joint. You can add multiple joints, or you can have a complete flexible system. If we look at, for example, the evolution of windscreen wipers. And the first models on the 4T model, and there was just a simple immobile steel windscreen wiper, let's say, that was mobile. Next step within the windscreen wiper was to add several joints, so it made it more flexible. Now the latest generation of windscreen wipers are completely flexible. That's an example of how we can make variations. Now, if we start from that product DNA, we list up all these properties and we look how we can change them and what might be possible advantages to change these properties and to adapt them. And what's also interesting, you can go and look what other products, other technologies have gained by changing properties. Because then actually you can find new or improved functions and add it to your system. And I will conclude by giving you some examples that I brought here as well. I will try to show them, but I also have them on the next slides, I think. So, for example, let's start with the example of the glass. Okay, I listed up the properties of this glass. And for example, one thing is that normally the glass of the glass, if I can say so, is something solid. It's full. Now, actually, what might be the advantage of making it hollow, like they did in this glass, or I hope you can see it on the slide here, that's actually what could be the advantage of having a hollow glass here. It isolates, exactly. So you can compare it to what they do to windows, for example. You can have your hot coffee, during winter and still hold the glass. Or in summer, you can have your iced tea in your glass and it won't heat up that quickly because when holding your glass. Yes, another example is, for example, another property. You always have the property mentioned on the right-hand side or your left-hand side. Actually, what can a product tell you or a technology tell you? Can it give you feedback? Can it give you more information? For example, probably there are some young parents here within the room. If your little child is sick, you know all the annoying sometimes procedures you have to do to actually measure the temperature of the little baby. Now, a nice solution is actually to combine and to measure the temperature within a dummy. You give it to your child and it immediately gives you feedback on the temperature of the baby. Another example of particular property might be adding holes or making something porous. Okay, something can be just solid, you can add holes, multiple holes, completely porous. So there's again a lot of variation possible. And again, for the food area or for the kitchen area, you probably all had maybe the bad experience of losing your spaghetti into the sink when you actually try to have the water out of the pot. So what they actually did here is a very nice example by adding little holes into this. And you put it on the pot, and you can actually easily pour out the water without losing your spaghetti. Okay, next example is for the people who plan to go skiing this winter. When you actually drive with your car and it starts snowing, you need chains. Okay. Now, actually, another possible variation of properties might be the state of your product or your technology. Something can be something can be solid, or can be liquid, can be gas, or can be field, electrical, magnetical, and so on. So these are 4 possible variations of the property state. Now, the new innovation I show here is actually very easy. These are liquid snow chains. So it went from solid, we all know the solid snow chains. This is actually a liquid snow chain. You actually put it on the tire, it hardens up, and it gives the same effect as steel snow chains. But you can use it on any type of tire. It's very easy to have it in your car, and it automatically removes when driving on a normal tarmac. It automatically removes after 5 or 10 kilometers of driving on the road. So it's very convenient to use, much more convenient than the traditional snow chains that we all know. Another example of a possible variation of property is automation. Something can do, let's say, nothing, can be very passive, or it can actually respond, or it can do things for themselves. The best solutions are things that do things for themselves. Now, for example, this is quite an interesting one. You know that in summertime, when you want to kill flies and you have to spray the poison, you actually spray let's say a whole cloud of poison to actually have that little amount of poison onto that tiny little mouth of the fly or the mosquito. Wouldn't it be nice if the poison automatically finds the fly? And it's like maybe you know the Patriot rockets. It's this kind of Patriot rockets for killing flies and insects, because when you spray this, it actually, you give it a static charge. So the fly flies, is not hurted, so it tracks all that statically charged. So they claim to have more than 60% hits thanks to this self-seeking, insect-seeking spray. Finally, you know that the best solutions are the simple solutions. Okay, so you all know Mars bars and Snickers and Twix and so on. Now, actually, how do you open the packaging? You tear it. And why do you tear it, or where do you tear it? Exactly, where you have those protrusions. I gave you already the answer. So, but this is a technology or a solution that exists for maybe 30 or 40 years already, I don't know. But it took so long before actually we had the idea of moving this or copying this solution towards Scotch tape. You know, probably millions of people have already broken their teeth or whatever trying to break the Scotch tape. So actually what Prit did here was to add the little curves on the sides of the Scotch tape so that you can tear it wherever you want, so you don't have to break your teeth to actually cut it without scissors. Okay, that's my story. Maybe a last one, as I see, or two more examples that are not on the slide, is that another example of flexibility might also be something and the example that I gave, something can be immobile or jointed or completely flexible, is this nice example of Tupperware, which you probably know. You may all have the same problem within your kitchen, that you have to store all your little pots and they don't fit, and next time you open the closet, it falls, you get all these pots on top of you. Now, a nice example that Tupperware found as a solution was to actually add flexibility within the sides of this pot, so you can actually, like this, you can choose it and choose the content you want. And if you don't need it, you just have to, you can compress it, and you can easily store it within your cupboard without losing any space and nicely stack it. So it's a nice example of what the change of a property like flexibility might add to your technology or your product. And the last one, as I said, maybe a similar example as the insect-seeking spray is this sports shoe, which actually is an intelligent sports shoe. Now, why is it intelligent? It adapts automatically to the hardness of the soil you're running on. When you go running in the woods or you go running here in town, it's completely different. Okay, so this shoe has sensors inside, and it automatically becomes more soft or harder according to the surface on which you're running. And this, for example, is a technology that actually could also be used, for example, in tires. It depends also on the temperature and so on, and on what kind of roads you're driving, what must be the pressure within your tires. So this technology might be transferred toward tires to also have the same solution and to actually have better and more intelligent tires.